Here are some quadratic equations, and each one of these, the graph of each one of these will be a conic section because they're quadratic equations. And I want to talk to some moment about how to identify what type of equations these are. First of all, you should be familiar with what the equation of a parabola looks like. A parabola is something like y equals x squared. That's an example of a parabola. And the key thing to notice there is one of the variables is squared and the other one is not. So in each one of these, since both x and y are squared, none of these are going to be parabolas. So if I got rid of this 2 here, this would now be a parabola. And y equals x squared opens vertically. This would open vertically also. But if I changed it and got rid of the exponent on x, it'd be a horizontal parabola. So parabola has one of the 2 variables squared, but not the other one. So we don't have an example of that on this page. Another equation you should be familiar with is if I say x squared plus y squared equals, I'll say 9. You should recognize that as the equation of a circle. It's centered at the origin and the radius is 3. So it's good to be familiar with some basic graphs. Y equals x squared, the parabola opening upwards. X squared plus y squared equals 9. That's a circle centered at the origin, radius 3. But the key feature here is both x squared and y squared have the same coefficient 1 in front of them. If I took this equation and changed the coefficient to 4x squared plus 1y squared, it would no longer be a circle because I'd be distorting it in one direction but not the other. And that would be an ellipse. So let me write these down separately. So we can remember that if we have a plus involved, we have x squared and y squared both, and a plus involved, it's going to be a circle or an ellipse. And the ellipse happens when there's different coefficients, because we can think of it as being a circle that's been distorted in one direction. So just glancing at these problems now, keeping that in mind, the plus is going to indicate a circle or an ellipse. A minus, here we have an x squared and a y squared, but it's subtracted. That's going to be a hyperbola. So I'm going to put h for hyperbola next to each of those. And it's a hyperbola because those are subtracted. The plus is going to be a circle or an ellipse. It's really the same type of shape. But in the first one, if I multiply through by 25 to clear a fraction, since they're both 25, the coefficient on x squared will be 25 and also on y squared. So that will be a circle. And for 3, since they're different, and it's still plus, that's an ellipse. So I'll abbreviate here, E for ellipse. Now another question that comes up is where's the focus, and or where's the center? And the center we can read off from the equation itself. For example, the first one has a center at 4, -2. If I plug in 4 for x, the first term becomes 0. If I plug in -2 for y, that second term becomes 0. That tells us where the center is. 4, -2 is where the center is. And just for another example, this ellipse will be centered at -3, 5. But we can also talk about the focus of an ellipse or a hyperbola. There's 2 of them. There's 2 foci for an ellipse and hyperbola. And to find it, you have to find the c value. And what I remember here, when you try to find c, it's kind of like the Pythagorean theorem. In fact, if we're dealing with a hyperbola, it looks exactly like the Pythagorean theorem, a squared plus b squared, where a squared and b squared are the numbers in the denominator. For an ellipse, it's reversed. Instead of a squared plus b squared, it's a squared minus b squared, and where a squared is the bigger of the 2 in the denominator. So for this ellipse here, it's going to be c squared will be 169, that's the a squared, minus the 25, which happens to be 144. So for that one, c would be 12 in that example. But just as a mnemonic device to remember these formulas, I think So back to the ellipse. I think of the ellipse as being a distorted circle. And since I'm familiar with the equation of a circle, that reminds me that the ellipse has a plus in the equation. And the hyperbola is the other one. It has a minus in the equation. And then when you find C, I remember for some reason it's reversed. We can think about why that's true, but I just remember it's the opposite. So the plus in the equation tells me it's an ellipse, but then I have a minus when I'm trying to find the foci. And then for a hyperbola, it's a minus in the equation, but then it's a plus when I try to find C, which leads us to the foci.